Welcome to EDU World Space.
Alright guys, we're doing problem number 72 of chapter 9 in Chemistry Central Science. So they want us to sketch the molecular orbitals of our H2 minus ion and draws and draw its energy level diagram. You can see that on the screen. We have our non-bonding orbitals, we have our bonding sigma orbitals, and we have our anti-sigma orbitals. So write the electron configuration of the ion in terms of its molecular orbitals. So the electron configuration is going to be S is going to be for H2 minus, sigma to 1s, sigma star are 1s. Because we have two electrons in our sigma orbital, we have one electron in our anti-sigma orbital, and this is all with 1s electrons. So calculate the bond order. So if we have two electrons in our sigma orbital, we have a bond order of 1. However, that's partially canceled out by the weakening we get by having an electron in our anti-bonding orbital. So where our bond order is going to be 2. Sorry, bond order is going to be 0.5. Okay, suppose that the ion is excited by light, so the electron moves from a lower energy to a higher energy molecular orbital. Would you expect the excited state H2 minus ion to be stable? No. Because if you were to move this electron here from your sigma bond to your anti-pi bond, it would lead to a scenario where you have two electrons in your anti-bonding orbital and one electron in your bonding orbital. So you would have so you wouldn't be able to form any bond because the electrons in your anti-bonding orbital would cancel out the electrons in your bonding orbital. So you can't form any kind of stable bond. Which the following about part D is correct. 1. The light excites an electron from the bonding to the anti-bonding orbital. 2. The light excites an electron from the anti-bonding orbital to the bonding orbital. Or 3. The excited state is that there are more bonding electrons than anti-bonding electrons. So 1A. The light excites an electron from the bonding orbital to the anti-bonding orbital. That is correct. 2. The light excites an electron from anti-bonding orbital to bonding orbital. That's fundamentally wrong because when you excite something, you go from low energy to a high energy. So you fundamentally cannot excite something from anti-bonding to bonding because as you'd be going from high energy to low energy. That's not what excitement is. Now, 3, in the excited state, there are more bonding electrons than anti-bonding electrons. Also incorrect. In the excited state, you would have 2 anti-bonding electrons and 1 bonding electron. So number 1 is correct.